Soon you got this Technics SA5650, late 70s, early 80s, I think, amplifier from Sony in as a repair. It's one of my sort of fairly regular customers who brings me stuff to repair. He's bought this in and it's on loan or borrowed or whatever from a friend of his who says that it's got high distortion, and he wants to know if we can do anything to repair it. These slightly unique amplifiers, these Sony models of this era and this sort of like stature, the more sort of upmarket models had this v-fet front output stage in them. I'm not entirely sure what the benefits are. I know FETs are probably slightly more efficient, but I don't know what a v-fet is, and I'm about to have a look that up on the internet so we can find any information about it. Now, what's interesting about this is I was looking at one of these for sale on eBay a couple of years ago, and it was boasting that it had this v-fet technology, but he said that his particular one didn't work. And I thought, well, it might have been an interesting project, but I thought before I get too involved, I better check to make sure that the v-fets are still available, and they're not. These v-fets for these transistors, I've never seen one come up for listing. It's obviously that because it's a specialised form of field effect transistor, they're very hard to get hold of. I need to try and have a look to see if I can find out exactly why they're not available. I did also look into sort of like replacing the v-fet with maybe a conventional FET, but that didn't look like that was possible, not without major modification to the circuit board, which was just not worth it. These are pretty average amplifiers. They're quite powerful. I think they're rated about 80 watts per channel, which is in its day colossally powerful amplifier. I'm not entirely sure about the specs of this unit, but so what we're doing this evening is just having a look on it on the scope initially, and then maybe run it through the distortion analyzer if we can't see anything obviously wrong. But so I powered it up and it's warming up on the bench. Need to go have a look inside just to see if we can see if there's anything obviously gone wrong. Interesting to have a look inside and see what these v-fets sort of look like in physical form, rather than I just imagine they're probably like a TO3 device. I'm not sure. So the next step what I'll do is I'll connect the amplifier up to the maybe the dummy load, and we'll put it on the scope and have a look at the waveforms and see what we get. I've already connected up on the dummy load. Dummy load set to 8 ohms. I'm injecting a 1 kHz tone in from the audio analyzer, the HP audio analyzer. We're just going to wind the volume up and just have a look at the waveforms. So just have a look. Okay, here's our sine wave coming up. Looks okay. One amplifier's lagging behind slightly. Well, that looks okay. Have a bit more. Oh, here's the output. Okay, we've got a heavy clipping on the top of that waveform. Can you see that? The top of this waveform's clipped. Drive it a bit harder. Oh, there's something seriously wrong there. And it's clipping the bottom as well. So if that's a complementary amplifier, I'll suggest it's possibly got a power supply problem. Oh, that's nasty, it squares right off. So there's where your distortion is. It's probably not too bad at those levels, but it's clearly higher than it should be. So I think what we need to do is have a look inside this amplifier and see if we can find anything obviously wrong, and then maybe you might be lucky, it might be just like a burnt out resistor or something. But let's have a look at this amplifier, take the top off and have a look. Okay, just out of interest, we'll have a look at the distortion on the scope, on the analyzer, see what we've got. So the right hand display is showing our total harmonic distortion. Let's put a bit of filtering in to get a bit of noise. So I'm going to turn the volume up, and you should see the levels drop back as the volume gets a little bit higher, and then 0.2% is 0.3 is pretty high actually, and you find as it runs into the distortion, there it goes, 19-20% distortion. So yeah, we can clearly see that on the waveform, but we'd just be interested to see what the figures look like, and it's you're in the sort of 20%. Anything above 1% is clearly audible, especially on sort of like quiet passages of music, but that sort of level, they will sound horrendous, and you damage your speakers, and the amplifier's clearly got a serious fault with it. So let's rip the top off and have a look. Okay, looking inside, it's a pretty standard layout really. This is the power supply to the left here, just a filtering for the supply for the transformer. Down at the bottom here we've got sort of like selector switching and stuff like that. This is all our tone control amplifiers here, just down here, and this is other selection stuff for record playback and various other things. So our preamplifier is basically pretty mainly done on this bottom board here, and this is our power amplifier stage. Now this is the heavy heat sinking, obviously, for the FETs at the bottom. It's lovely, beautifully laid out, and looks like a nice amplifier to actually work on. Lots of space, actually, a lot of room, but a lot of heat sinking as well, so it's obviously quite a powerful little amplifier, though the transformer isn't particularly large. So what we need to look at really is, I think the first thing we need to do is possibly try and get this power amplifier section out. I don't really want to strip down too far if the FETs have failed. But what we can look at initially is the inputs to the amplifier, which is on this plug here. So we'll pull that off slightly, and I can get my scope in there. Just make sure that the inputs from the output from the preamplifier isn't distorted. We want to make sure that we're not sort of barking up the wrong tree, and it is the power amplifier that's causing the distortion. It's not a late preamplifier problem. So I think that's what I'll do first. I'll get the scope connected up with a probe, and we'll have a look at the outputs of the outputs of the preamplifier input to the power amplifier. So this section here, this is basically the output. This plug is the output of the preamplifier, and you're going into the main amplifier here. Let's have a look at that, see what the distortion looks like there. Alright, let's have a look at the inputs to this. So this is the left-hand input to the power amplifier. Okay, that's nice and clean. So there's no problem with that. No distortion there at all. Right-hand side. Yeah, nice and clean. So definitely got a power amplifier problem. So we've tracked it down to that this board here. It's definitely this board along here that's got the problem. We need to just have a look so we can see anything obvious, and try and work out how to check these v-fets. Okay, it's going to have to be handheld, I'm afraid. This is the with the screen off, so you can actually see what's going on inside. And indeed, they are sort of like a TA3 device. There's the components down the bottom there. Looks like a sort of traditional push-pull, but which is interesting. Looks like it's got sort of like the equivalent of emitter-follower resistors. So I'm not sure if these v-fets will work in a sort of like in the conventional push-pull amplifier or not. And this is the other side. And there's nothing obviously wrong. There is a bit of sort of like blackness going on down here. I'm not entirely sure what it is. Maybe that FET's got hot. And FETs are notoriously difficult to test in circuit, so I'm not sure if I'm going to be able to test them that easy without taking them out, but it looks like you just unscrew them and take them out and check them. So what I might do is just whip the bottom of the unit off, check the FETs individually, try and find the FET that's failed, and if it is a FET of course, and ascertain which side it's gone and which transistor's gone, and mark it, and let the customer know, you know, that the v-fet's failed. What does he want to do? I think he was planning on, if we couldn't get it working, is sell it for spares or repair, obviously with one channel dead. We'll check a few other things as well. You may have noticed here these blue resistors are fusible resistors. I mean, the chances are that if one of these fusible resistors is gone, it's gone because it's protected something. So we might be able to find something through that as well. But these are nice amplifiers to work on. These are the sort of amplifiers I prefer working on, because you can get to stuff. You're not all crammed in there. There's not just one chip doing everything. There's a bit of thought gone into these things, you know, and they're designed to be serviced. It's just such a shame you can't get the v-fets of these things anymore. But let's have a look. Let's get the bottom off. It might not be a v-fet. It's more likely it is, but we might be lucky. Might be able to find a driver, like a conventional driver, like one of these pre-drivers to the power amplifier stage that's gone. But looking at that waveform and the way it sort of collapses, it suggests that it's not passing enough current, and something's not been turned on. It could be even one of these emitter followers, or source drain followers, or whatever they are. So let's get the bottom off and have a look at the transistors. Okay, so here are the J-FETs underneath, TO3 packages. So they're 2SJ18s and 2SJ60s. It's just, it's just a standard, it's probably maybe a Sankin or something like that, but it's got Sony written on it, and it's JH55. I don't know what that means. But these are the transistors. Now these are just in pluggable sockets, which is nice, so we can get these transistors out and test them. Now I need to just have a look on the data sheet and see how you, well, if we can find the data sheet, find out how you test these transistors. I assume you test them like a normal FET. So basically you put a bit of voltage on the gate and it turns the FET on. So see if we can find something like that, some information on these, and ascertain how to test them before we get them pulled out. There's very little information about testing these FETs. There's a couple of things on the radio forum that's saying you should check for sort of like, they should be fairly low resistance. They're basically like conducting all the time, very similar to J-FETs, but they call them vertical FETs. I think it's V for vertical FET. So what I did is I took the transistors out and compared them all, and they all look very similar. This is the channel that's failing, or this was the channel that's failing, and I compared the junctions. I took the two 60s out and compared the two transistors. They looked exactly the same conduction wise, or within sort of a few hundred milliohms, same as the other side. And I'm thinking, well, that's, that looks exactly the same as well. So what I'm experimenting with now is the transistors with dots on. This is more for my own references. Dot here, dot here, dot here, dot here. Originally came out of this channel here. So any transistors with dots in them initially came out of this lower channel here, or which I think is the left channel. This is the channel that's failing. So what I've done is I've transposed the FETs that were in here and put them up here. So the 18s are now here, whereas before they were down here. I want to look at the distortion again on the output and see if it stays on the same channel. If it does, then I'll swap the other FETs as well. And if it still remains on that channel, we can ascertain that these FETs are okay. This is the problem. I can't really test the FETs because no one sort of knows of a sort of like a definitive way of actually testing them to see if they're okay. So let's power it up again, have a look at the waveforms and see what we got. Okay, so basically what I've done now is I've transposed all these field effect transistors to the other channel. So in theory, if one of these FETs was the fault, then the distortion would have cleared. So that's a moment of truth. Let's have a look. Ah, look at that. Okay, so that would suggest that all these FETs are okay, which is excellent news, because these are the parts that are really hard to get hold of. The next tricky part is to go through and try and work out what the hell's actually wrong with this amplifier, and that's going to be on the driver board most likely. So I think it's going to be a passive component check probably first of all, just to make sure the capacitors are okay, and then check some of those emitter and those fusible resistors and have a look, see if any of those have failed. I'm just trying to work through this amplifier and try and work out what's going wrong with it. All the components seem to appear to check okay. Capacitors seem okay. I know it probably needs recapping, but there's no open circuit capacitors I can detect with the LCR meter. And it seems to be current related because the waveform deteriorates with the amount of current you draw out of the amplifier. If you're actually putting the output straight into an open circuit, there's no problem at all with the a clean, non-distorted waveform. As soon as you pull any current out of it, it becomes very distorted. So I'm looking at the current drive circuit, and if you familiarise yourself with an audio amplifier, an AB amplifier, you've got sort of like series transistors that boost up the voltage basically, and then you go into the push-pull stage of it, and the push-pull stage is the bit that does all the current and produces the actual output power sort of thing. So I'm looking at the late driver section and also the main output transistors. Now we've come to the conclusion that the output transistors are okay because we swapped them, and the channel is still on the fault's still on the same channel. I need to just double confirm that because I'm now wondering if I've actually moved up to the top channel. So it could be a possible that one of the FETs has actually failed. Lost my way a bit with this. So I might need to put the transistors back to where they were originally and see if the fault still remains on this channel. But it looked like last night when I was testing it, the faults, didn't move with the FETs changing. But at the moment it looks like we've moved to this top channel, and this is the channel that's the problem that's faulty. It's the right-hand channel. And if you look at the driver of this transistor, you see that the first waveform is the output stage, and the second one is the drive transistor. If I look on the other drive transistor here, you see it's not clipped. It's nice and symmetrical, but it's still clipped on the output. So I think we've got a problem still with a late driver stage, or still looking a bit like the output transistors have failed. But I need to confirm this. I did a diode check and did all the checks that Sony suggests for checking these transistors, and they all came up clean. But I think I need to put them back to where they were, just to make sure, confirm this fault doesn't actually move with channel swapping.